Hello everyone. In this video, I am discussing the functioning of the cell under opposing external potential. Before watching this, please watch the videos which I have already posted on electrochemistry, in which I have already discussed about the functioning of the normal electrochemical cell and the differences between electrochemical and electrolytic cell. So please watch those videos. The playlist is already made under the heading electrochemistry. So in case to that electrochemical cell, we are attaching some external potential. The same example we have taken here: zinc rod dipped in zinc sulfate, copper rod dipped in copper sulfate. They are connected by a salt bridge. So this was the normal thing which was happening. The current was flowing from cathode to anode and the electrons were flowing from zinc to this side, copper side. That is a normal in case we do not attach it, right? But now in case we are attaching the external potential, we are applying the external potential, then what's going to happen? Now first thing is, just to remind you again, if you take copper and zinc, what was the cell potential we calculated? The cell potential for this particular cell is calculated as E cathode minus E anode. What was the cathode in that case? Copper. And the potential for copper is 0.34 volts. Minus zinc was 0.76 volts, and when you calculate, it comes out to be 1.1 volt. Okay, so 1.1 volt is a cell potential of this cell if you take zinc and copper. Now this electrochemical cell is if connected with some external potential. So I am considering three cases. One case, the external potential is lesser than 1.1. So why 1.1 I am telling you? Because we are talking about zinc and copper, of which the cell potential is 1.1. That's a normal one, right? In case this is not connected. Now if you connect the external potential with the potential lesser than 1.1, then what will happen? Then the normal process will occur. That means I am writing 3 points here. In that, what will happen? The electrons will flow as usual from zinc rod to copper rod, from zinc to copper. As it was happening without this, the same thing will happen in case the external potential is less than 1.1. Electrons will flow from zinc to copper. First point. Second point, current flows in the opposite direction. Current flows from copper to zinc. It is reverse. Third point, zinc rod is acting as the anode and copper is acting as cathode. And all that we have already discussed in the previous video, that zinc, because it is acting as anode, it is undergoing oxidation. It's undergoing oxidation. Oxidation means loss of electrons. So electrons from here were going the other side, and from here the zinc ions were going within the solution. And when the electrons go this side, the electrons are being picked up by cupric ions in the solution and they move towards the rod, and these cupric ions, they accept those electrons and get deposited here. So copper rod gains weight, zinc rod loses weight. So three main points you have to remember. In case the external potential is less than 1.1, then the normal process will occur as it was without this. Zinc was acting as anode, copper is acting as cathode. And mind it, in electrochemical cell, cathode is positive, anode is negative. Right? Now let's consider the second case. In the second case, the external potential, that is the E external which is connected, E external is more than 1.1. Right? When it is more than 1.1, the reverse direction the electrons will flow. That means in this case, the electrons will flow from copper to zinc. Electrons will flow from copper to zinc in this direction. And what is happening to the current? In the reverse direction. Current is flowing in the opposite direction. Current flows from zinc to copper. That means completely reverse direction the current and the electrons are flowing. Okay, and in this case just observe, very very important. Zinc acts as cathode, copper acts as anode. Copper acts as anode. That means copper is acting as a negative electrode and cathode, which is zinc, is positive electrode. That means very very important thing, in under this condition, when the external potential is greater than 1.1 volt, the cell acts like an electrolytic cell. In case you are asked to write down under which condition the electrochemical cell will function like electrolytic cell, you are going to write down when the external potential is greater than 1.1 volt. So that under those conditions, copper will act as anode and zinc will act as cathode. So under those conditions, the normal electrochemical cell will function like a electrolytic cell. Got it? Now we will consider the third case, when the external potential is equal to 1.1. Why 1.1 we are considering? I already told you, for zinc and copper the E cell is 1.1. And now if the external potential, the battery which is connected, is also 1.1, then what will happen? Then you see nothing will happen. There is no deflection found in the emitter. So you will write down in this case, no flow of electrons. Second case, no flow of current. Third case, no chemical reaction will occur. Under this condition. Right? So these are the three important questions. Many a times if these questions are asked where the figure is drawn, looking at the figure, you have to decide like which external is more or less or equal, and accordingly you're going to answer. Okay? So I hope this video was fruitful to you. Okay, thank you for watching.